Welcome to Making Art with AI. This is a webinar that is bringing together three amazing, interesting researchers and artists to talk to us about the current state of art making in music and in visual arts, given the recent developments in the last few years of generative models, deep learning models that have the ability to really make amazing examples of images, sounds, text, things like AI songwriting, fiction written by GPT-3, or many of the interesting images that some of you have seen with like DALL-E 2. Before we get into it, and before I introduce our Aaron Hertzmann, Ana Huang, and Moises Orta Valenzuela, I wanted to just let you know about a couple of other events coming up, both hosted by our Northwestern Center for Human-Computer Interaction and Design. So I'm just going to share the screen here and say that this is part of a series of events that we're doing on the web that I don't think you should miss any of them. Coming up in just a few days, we're also doing a panel on tech, media, and democracy. And this is bringing together three other thought leaders to discuss what happens to democracy in an age of, well, Facebook, AI-generated posts, and social media in general. And this will be just like our current session, happening at 4 o'clock Central Time via Zoom. And the people that you'll be hearing from are Chris Bale, Moore Naiman, and Rebecca Trumbull. And this is hosted, it's not shown here, but it's hosted by our own Agnes Horvat. If you are interested in that, you might also be interested in Dean Kamen, who is from DECA Research and Development. And they do all sorts of great, interesting things, prosthetics, the Segway Human Transporter, iBot, lots of stuff. And he'll be speaking on Friday, May 13th, again at 4 p.m. This one is a hybrid Zoom and in-person event. If you are interested in any of these, all of these events, I encourage you to go to our website, hci.northwestern.edu. That address again, hci.northwestern.edu. And I don't know if I can put that in the, normally I'm not used to webinars. So Michelle, can you tell me, can I put something in a chat here? I only see question and answer.
We don't have chat engaged, but we can share the information with participants following the event.
Okay, we'll follow up with that. And if you want to follow us on Twitter, if you want to see what the HCI Center is doing on Twitter, I guess I'll just, oh, I know what I'll do. I'll share something else. I will share this. There's our website. There's our Twitter handle. If you'd like to find out more about what is going on in Northwestern in the area of human-computer interaction, then I would say those are two great ways to find out. Come to our website, check out events. The events I just mentioned are listed on the website along with registration information, and the Twitter handle will also tweet out a variety of things. Okay, so those are the commercials for the upcoming events. Now what I want to do is I want to actually start this event, and it is my great honor and privilege to get to introduce three amazing artists, scholars, researchers. If you wouldn't mind putting on your screens. So the first one I want to talk to you about is Aaron Hertzmann, and he is someone who both at Adobe and well, I guess now also the University of Washington, but prior to that at the University of Toronto, has been developing, writing about, and creating all sorts of great work in computer graphics, computer vision, machine learning, human computer interaction, and art. He's an ACM fellow and an IEEE fellow and a very interesting person. And so he's going to lead off this whole thing with his overview of artistic creation in the world of machines. We're going to follow that up with Anna Huang, who is a research scientist at Google Brain, as well as a Canadian, what do you call it, a CFAR AI researcher. And so is that named after the data set?
I had that confusion initially.
Oh, I think your mute is on.
I had that confusion too.
Still muted.
I can hear Anna, and CFAR is an organization.
Oh no, I can't hear either of them. What's going on? It's very important we hear from them. Okay, Moises, can you try talking for a moment?
Yeah, can you hear me? I can hear everybody else.
Can the rest of you hear? Okay, it must be my local sound. Well, maybe it's working now. I'll just say, as long as we're at this, I'll just mention the third person. Moises Horta Valenzuela is a audiovisual artist, currently based in Berlin, but originally from the Americas, from Mexico and the United States. And he works at the sort of forefront of creating interactive, artistic, AI, music, sound generation. And so we've got this wonderful sort of set of three people who are going to talk to us about, sort of an overview of visual arts and machine creation, sonic arts and machine creation, and then someone who's working with these things as a current working artist. What we're going to do in terms of question and answer, I see some questions popping up. Oh, everyone's telling me everyone can hear except me. Okay. Hey, actually, could one of you say something now? Did I fix my audio?
Test.
Ah, yes, I fixed my audio. Thank you. What we're going to do in terms of format is each one of them is going to speak about their area of expertise for a while, and then we'll take it on to the next one. Once all three of them have spoken, we're going to start a panel discussion and also open it up for questions from the audience. If a question occurs to you that while it's going on, just feel free to type it in the chat, and I'll try and remember to go back and look at those and speak your questions aloud when we get to that portion of the event. So without any further ado, I'd like to give a warm welcome to Aaron Hertzmann, who's going to take it away. So Aaron, please.
Great. Thanks so much for inviting me and for the kind introduction. I just hit share, so hopefully now you're seeing my slides, or you will be momentarily. And I'm just going to double check that I have audio and video. Great. Okay, great. So as I'm sure everyone's aware, these past few years have been this amazing time for art being created with AI. And as we'll see from our next speakers, I think this current trend began with the Deep Dreams method. This is where it became very visible to a lot of people. That was developed at Google. And soon these things were being shown in sort of ad hoc art shows. So this is one from here in San Francisco, sponsored by Google, that showed Deep Dream and style transfer artworks. And soon these things showed up in more major art venues. So this is a work that you've probably somewhat notorious, was auctioned for $500,000 at Sotheby's with an image generated with GANs and signed with the GAN loss function as on the image. And now these became part of the academic literature much more. So here's a very interesting method called creative adversarial networks. And in the abstract for the paper, the authors claim we propose a new system for generating art. The system generates art by looking at art and becomes creative. So these are pretty bold statements that the authors are making about their work. And this is picked up by the media. So we have news headlines that say artificially intelligent painters invent new styles of art. AI artist creates its own painting style. And so all this discussion around these AI software tools making art becomes about the artist, the software being the artist. And this creates backlash. So here's a video of Jerry Saltz, who's one of the preeminent art critics in the world, talking about these things, about the creative adversarial networks paper. And in particular, notice the agency he assigns to the algorithm.
Initial thoughts, incredibly dull, generic, boring. The programmers are not freeing up the program. I want the robot to tap into its inner robot. Be free.
So it's hard to tell exactly how serious this is, but a lot of this public discussion is really accepting on face value the idea that the computer is the artist, is just not a very good artist. It hasn't bared its soul. And so this question is around in lots of different forms. Can computers create art? Can they be artists? And it's really hard to actually tease apart what exactly is the question when we ask this. Some people say it's just a matter of technological capability. A lot of people here in Silicon Valley just seem to have the view, it's like, well, we have enough megaflops in our GPUs, that means we can, the computers are good enough, or we have our deep networks sufficiently well trained, they make good pictures, therefore they are artists. Conversely, a lot of people I talk to seem to say, of course not, art requires intent, so therefore a computer can't be an artist. And I feel like there's some intuition there that something's missing, like being human, having consciousness, or humanity, or having a soul. And I think these intuitions, if we say it out loud, it sounds kind of like a religious argument. So I think it's a little tricky to figure out exactly is there a scientific statement of what we mean by these things, or is there anything, or is this just superstition? And so really the question I want to ask is, will we ever create a piece of software or some AI as the author of the artwork? And we discuss a lot of aspects about that. And so the main points I want to make here are that AI tools are just like any other technology. Like other pieces of software, they are tools for artists. They advance the field and they empower artists. So that's sort of my answer to the question in the title of this seminar. And moreover, I think that only social actors, which right now means humans, can make art. And it means being very specific by that. So I'll explain that later on. Third, I think there are scenarios where AI could be considered artists, but I think these are really unlikely. And yet, nonetheless, this is just an exciting time for people making new kinds of art and new kinds of expression through these new kinds of tools. So I think it's worthwhile looking back at the history of how technology has transformed art, because this is not the first time that these kinds of questions have arisen in society. One example of how technology has affected art is oil paint in the 15th century. Van Eyck developed oil paint techniques that had a lot of visual advantages and working advantages over the previously dominant technique in the Western tradition of fresco. And you can see here he could get much richer tonal ranges and details than Michelangelo can get with fresco. Within the Western tradition, there was a long trend towards increasing realism in visual art. And partly the artist's identity was tied up so much in their ability to create these illusions of reality. And it's really hard to imagine today in our lives where we're surrounded by photography and magazine and movies and web, how unusual and special it must have seemed at this time to be able to go into someone's collection and see pictures that look so real. Is a very unusual thing. So the artist's identity was very highly tied up in being able to create these illusions of reality. Then photography was slowly developed. Here's some early, this is considered most likely the earliest known photograph from 1827. Hobbyists started playing with it and they created this is the first Instagram of someone's meal in 1837 and the first selfie. But the real debate and discussion started in 1838, I believe, when Daguerre publicly demonstrated his method, and the French government bought out his patent so that anybody could use his technique. And immediately, this was a threat to artists. So one classical painter, Paul Delaroche, is quoted as having said, "From today, painting is dead," because it seems like the photography takes over the job of the artist, which is making realistic pictures. Now, it did have some significant effect in portraiture. So in 1838, if you wanted a high quality portrait made, you had to be quite wealthy, able to sit for a long time for a portrait, and you can get something like this. For the middle classes, you could get silhouettes made, which were not as high quality as portrait painting. So very quickly, within a few decades, portrait photography took over for these other kinds of portraiture. And even though it was inconvenient, you had to sit in your chair and grip the armrest for 10 minutes and have your head braced, it was still considered superior or preferable to earlier kinds of portraiture that generally largely replaced silhouettes and other portrait painting. And it was considered to have harmed painting considerably and killed portraiture, especially once considered the livelihood of the artist. And within the sort of more fine art discussion, there was this long question of, is photography art? On one hand, there were the hobbyists and experimenters who developed the art form and experimented with techniques over decades, particularly the pictorialism technique from the late 19th century that mimicked some of the techniques of conventional painting. And within half a century, photography was accepted within the fine art canon. There were major exhibitions in the early 19th century. And today we don't really question whether some photography can be art. On the other hand, there were the traditionalists like grumpy Charles Baudelaire here, who wrote, if photography is allowed to stand in for art, it will corrupt it completely, thanks to the stupidity of the multitude. Presumably that's all of us. But really, it was a challenge to artists. So Whistler wrote that the imitator is a poor kind of creature. If the man who paints only the tree or flower or other surface he sees before him were an artist, the king of artists would be for the photographer. So artists began to think, well, maybe making realistic pictures is not what we do. Let's make things that photography can't do. So here's his sort of attempt at that compared to the photography of the time. Van Gogh, in his pivotal year, wrote to his brother, accurate drawing is not the essential thing to aim at, because reflection of reality in a mirror would not be a picture at all, no more than a photograph. So here he's saying that realistic pictures aren't even art, aren't even pictures, and art is about something other than making realism. So in short, photography became a real challenge to artists in conventions of themselves, and it really changed it. And I actually believe that the modern art movement, as we know it, would not have existed without the challenge that came from photography. So in short, when photography was invented, it looked like it automated art and replaced it. And many artists feared it and disparaged it. And what actually happened was we have a new art form called photography. The old art forms were invigorated and transformed as a result of this new challenge. Portraiturists were replaced with photo studios. And also, I didn't mention it, but image creation was also made available to hobbyists, so that people like us who are not working in studios are able to make pictures and create creatively in different ways. Now we all have cell phone cameras that we all take pictures with all the time. And so this is something that is accessible to many of us that would not have otherwise been able to make pictures in the same way. In the modern art era that followed, the notion of art was radically transformed. And I don't have time, obviously, to discuss the whole thing, but in a lot of ways now we really consider that whatever an artist does can be art. The notion of what art is has dramatically transformed. One important step in that, however, was the conceptual art movement. And some of these early conceptual artists were really doing generative artwork. In particular, I want to focus on Sol LeWitt, who created paintings as lists of instructions, and other people would actually execute on the paintings. And when he wrote about this development and the notion of conceptual art, he expressed it as the idea becomes a machine that makes the art. It's really the artist is the one creating the idea and not the physical artwork itself. And this is really a precursor to generative computer art. And really, AI art didn't start, or computer art didn't start with deep dreams. It goes back to the 1960s. As soon as people could make pictures with computers, they were experimenting with making art. But this is, in the 60s, it was back when people are physically plugging things into program. This is way before punch cards. And so obviously the artwork is quite different. So this is a field with a history as old as computer-generated imagery. One of the most significant 20th century computer artists or AI artists is Harold Cohen. He was trained in a Goldsmiths, I think, which is a sophisticated art school, and he made rules for himself for how he would paint. Then he discovered Fortran and said, why am I doing it by hand? He began programming these rules. And since then, for the rest of his career, he built more and more sophisticated software that would generate these artworks. And his work is included in a lot of major collections now. So this is something which has been around for quite a long time. Within the more mainstream world of computer animation, people look at Pixar movies and they think the computer did everything quite often. But really, this whole field of computer animation has come about as a close collaboration of artists and scientists. In the early days of computer graphics, the people who went on to found Pixar, like they first tried to go to Disney to convince them to adopt their software, and they spent a lot of time trying to convince animators who were frightened of the computer that it was not going to take their jobs away, that it's just a tool, it doesn't do the creativity. And people have had this misconception about computer graphics for decades. When you look at the actual process of making computer graphics with these tools, it is extremely laborious, and you can really see how it really takes skilled artists to make these movies. It's not just about the technology. In my own work, I entered into computer graphics research by developing tools based on my painting experience that would implement these ideas and automatically make paintings from photographs. And this is an installation that I made that was shown at some art shows in New York during my PhD. And you walk up to it and it makes a painting, and the painting keeps revising as you move around. But it's all based on a set of rules that I authored that tell the computer how and where to place the brush strokes. I also developed a machine learning method for these things. This is a style transfer method that takes the style of the painting in the upper right, of the pastel illustration, the photograph in the lower left, and transfers it to create the image in the lower right. And again, even though there's some machine learning involved, it's really all an authored system that's designed to create these kinds of images in a particular way. It's not some intelligence doing this for us. So in short, all of these examples of computer-generated art it's all things made by humans, and it's all things authored and controlled by humans. So one of my favorite AI artists is Helena Sarin. She worked a lot with GANs, and she compared it to watercolor painting, that you have to work with the watercolor, you have to learn to use it, but you have to control it. If you've ever used watercolor, it kind of feels like it has a mind of its own, and you have to learn to work with that. And she describes working with GANs in the same way. But yet, there's always been this hype. This is the first description of the perceptron in 1958 in the New York Times. The Navy expects it will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. And this is describing the perceptron, which is a linear classifier, which is not sophisticated enough. This is before the development of gradient descent backpropagation rules. It was not that sophisticated, just a linear classifier. And they're saying it's going to be conscious. And we see this hype translated into news and media representations. And I think these things are dangerous. Time is short, so I'm not going to talk about the details, but we've seen a lot of examples of how calling things AI or calling them intelligence has societal implications and can be damaging. And I think that calling an artist, an algorithm, an artist, can also do the same thing and give people a wrong impression about what's actually going on under the hood. And there's dangers to creating this AI as if it's actually intelligence. So that's where we are right now. But I think there's still a question in the future whether computers in the future can be considered artists. And it's a really hard question to answer.
Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece?
Can you?
And one thing to point out is that bad art is also art. It's not just about making great art. It's about making any kind of art. Now, before I make any predictions, I want to say that it's hard to make good long-term predictions of the future. People are terrible at it. We are all at least with specific predictions. If you ask people 60 years ago, what will the city of the future year 2001 will look like? They'll say, well, we'll be like driving to work on the moon in our moon bubbles. If you ask them what will the impact of computers on society be in the 1950s, they would say, well, the computer will be small enough to fit in the room of your house and calculate pi to 100 digits in less than a minute. Almost everyone, including science fiction writers, completely failed to predict the effect of social media, smartphones on our society, and these things have been completely transformative. And now we're seeing the same thing, these predictions about the effect of AI in society that are just all over the place, and I think pretty unreliable. So I want to go back to this idea, however, that whatever an artist does can be art. And I think then the real question is, what can be an artist? And For me, I find inspiring this notion of the evolutionary theory of our art. The idea that art is really a product of our evolution as humans, and the claim then is we create art for sharing and for gifts, for displays for fitness, for mating, for displays of social status and tribal affiliation, and for communication, especially storytelling. These are all things that our Pleistocene ancestors did, and these are all things that we do today, albeit in much more sophisticated ways. And the common thread here is that these are all about our social relationships. They're all things that we do for and with and because of other people. We are social animals, and we care a lot about our interactions and our role and our status with respect to other people. And so my main hypothesis is that art is something that can only be created by agents capable of these social relationships, in the sense of being social animals. Excuse me. So, as one counterexample, I point to natural processes. The natural world can be really beautiful, transforming, sublime, change our perspective, all of these different things that qualities that we often attribute to art. And yet we don't generally consider natural processes as part of, as themselves artists, in the same way we think of, we don't consider coastlines to be artworks in the way that we think of paintings as artworks. So if that's true, then we can make some predictions about when a computer could be an artist. Now, if we get computers that generally have human level AI and they have consciousness, then by definition, these things can be artists because they're just like us. But this is science fiction. It might never happen. Maybe it will take decades. But for sure, it will require a huge transformation in how we even understand artificial intelligence. Now, we do have things that are called social AIs or conversational AIs, like chatbots, like Eliza, Siri, Alexa, Cortana, Neko, Sume, Parotherapeutic Seal. And these are things that there are reports of people having social relationships with them, but they're isolated, and people often feel cheated when they discover they were just talking to a bot. So I think it's conceivable with some kind of transformation of our relationships with these bots. But again, this is science fiction. This is kind of an unlikely scenario in the future. In our current software, where you can just like pull some code from GitHub and do it.py and run the thing, I just don't see how you can consider these things to be artists. These are lines of code that execute instructions authored by a programmer and then run by a user, with someone may have curated a data set. All of these processes are driven by users. And I would say that those users who are running the process are really the artists and not the software itself. Nonetheless, I think it's an exciting time because new technology, as we saw with oil paint and with photography, it helps art stay vital and current to our societal interest in communication. And conversely, art that doesn't change grows stale. So art is always changing. And it's nearly impossible to predict specifically how these technologies are going to drive art. Always we can say that cool stuff is going to happen. One example of this is, here's Les Paul. He's one of the main innovators of the electric solid body guitar. He played nice jazz and swing tunes. And there's just no way, I think, he could have predicted how his invention of the electric guitar was going to change popular music and culture in the following decades. Now we're seeing lots of really cool, exciting stuff with people playing with all the latest tools, starting with Deep Dream, Style Transfer, GANs, VQ GAN. And now within the past few weeks, DALL-E 2 has been released. And this is still I'm still trying to process how this transforms our notion of computer creativity. But it's very clear there's something really exciting going on here. And so in conclusion, I very much believe that new technologies are tools that benefit art and that benefit artists and create new forms of expression and new ways of seeing. I believe art is a social activity. It's something we do because of and for the people, and therefore computers themselves cannot be the artists and will not be anytime soon. And it's a really exciting time to see all these new developments and new kinds of tools and new kinds of art coming about as a result. Thank you.
Wow, that was excellent. We've got a couple of questions that people have posted. When we get to the chat after the 3 talks, we'll come back to those questions. So keep your questions coming. Next up on the docket is Anna Huang, who will, I think, be focusing more in the audio domain than the visual domain. And please take it away.
Thank you, Brian. Can everybody see my screen okay?
Yep, it
Cool.
looks great, Anna.
Thank you. Yeah, I realized that in the webinar, we don't have as much of a feedback loop going on. Yeah, I really enjoyed Aaron's talk, and I think there's a lot of threads that we're exploring today. I wanted to kind of get us to think about co-creativity, like how people and AI can work together. I'm a research scientist on the Magenta team that thinks a lot about music and art and machine learning at Google Brain. I'm also an adjunct professor at MILA through University of Montreal. So I also advise students, graduate students there to work on projects at this intersection. So first, I want to talk a little bit about as a composer, what gets me really excited is one of the things is going to new music concerts, and in the process of listening to these new pieces, like there will be moments where I hear things and feel things that I realize that, oh wow, like I didn't know this was something we can communicate. I didn't know this feeling could be communicated through sound, through the interactions between the players and be shared and be acknowledged. And those moments are really amazing. It's like really a kind of expansion and a new kind of connection that I feel like we can build with each other. And back to kind of making music with AI, I think there's a lot of potential there. We bring a set of kind of perspectives, and AI sees the music in very different ways. And so it kind of allows us in some ways new ways of seeing. And so we've been organizing this AI song contest for the past 3 years now. And the whole idea is to explore this wide range of possibility in terms of what are these different modalities of co-creativity that we can find, and also to really accelerate the collaboration between artists and scientists, so that there's a feedback loop in terms of what do we want as artists, how can scientists kind of take inspiration and support that. So the first year this was kind of a Eurovision kind of in Europe, and last year we scaled it up to an international contest because we really wanted this to be also a cultural dialogue, that people from all parts of the world can be kind of experimenting with their own genres and own cultural traditions, and seeing how what role AI takes in this process, in this. So we saw a wide range of different songs from different parts of the world. We're also organizing it again this year, and the contest is really growing. And in June, you'll be able to hear some of the entries. So today I will cover 2 entries, but first I want to show a schematic or a kind of a workflow chart of what it takes to kind of make such an entry. And because music has many different parts, there's the sound design, there's the melody, there's the arrangement and everything. It's less of there's one model, for example, GPT-3 or DALL-E that these teams interact. Instead, they're constantly using maybe 4 to 8 different models for different parts of the process. And so it's a contest. So how do we evaluate human AI co-creation? So there's a couple of different axes. Of course, first the song itself. So we asked all the judges to first listen to the songs without knowing how it was made. And then the next step is really going behind the scenes to understand what is the process, because the process is where all the interesting kind of dialogue happens. So we have a list of questions that we ask the participants to kind of to guide them to write about their process. So as part of the judging process, we get to really read about what is kind of the nitty-gritty that they went through. So in particular, two of the axes is we really see, like, by involving AI tools in your process, how does it enable us to push the boundaries of creative expression? At the same time, the impact could be on the workflow itself, the workflow, the collaboration process, or the songwriting process itself. So you can imagine sometimes there's more impact on the workflow, sometimes there's more impact on the final result of, like, really being able to hear something new, and sometimes there's both. So in the next couple of minutes, I'm gonna walk you through two of the songs. One of the first song, it was the winning entry of this year, and we were really lucky that we had a jury panel from musicians like Imogen Heap to professors at CalArts and Berkeley to really kind of engage in this dialogue of music making and AI. So this first entry is an example of kind of pushing the boundary and creating these new interdependencies between songwriting and sound design. So this team, they wanted to kind of pay tribute to the first song that was sung by a computer. So there's a little bit of this parallel. So later on, you'll hear they're gonna use current neural networks to get the computers to sing this song, and how there's a lot of surprises they encountered. Okay, so this was the initial inspiration. And then the singer took this and kind of sung her version of it. Daisy, Daisy, give me your hand. And another route was in terms of creating the melody for their new song. They used an RNN to train on the melody from this Daisy bell, and then generated a lot of kind of variation. And then the composer worked on stitching these fragments together. So this is the version that they came up with to open their song. I wanna be untamed up there in the clouds, sending saints to. So it shares some of kind of the sentiment, the kind of the sweet and the of the original melody, and but at the same time, so the notes were kind of used to create this new melody, but the audio of what the singer is saying through these all different versions became they used it as training data to a model called sample RNN that trains music based on sample by sample, and this is what was generated. So you can hear it's not quite what we expected in terms of really imitating what the singer, but it was imitating some aspects of the singer, and it felt like this voice trying to be the singer, and it had all these emotional qualities that the producer really used as kind of a way to set the vibe of their song. So the next what you hear is the producer kind of putting all of this together and kind of creating that sonic world. So I'll let you go to our website to listen to the full song. But here, just to kind of highlight how this process really was this this kind of co-creativity where there was surprises on the way that kind of opened up new possibilities, and also being able to kind of transfer some of the music into the sound design. Oops. Okay, so the second song I want to highlight kind of more the impact on the workflow itself. So this is a song by Bob Stern and team. So their process was taking folk RNN, which is a model that can generate folk tunes, and then get Music Transformer to harmonize it with piano accompaniment to make a song. And sadly, this song was a lament to Bob's puppy. So first, I'm going to introduce the Music Transformer model, and then I'll play you the song that was created through this process. So Music Transformer is a little bit special in that it's trained on classical music, classical piano music, but it's trained on both, it's trained on the performances of the music. So it's from this kind of open piano e-competition where a lot of pianists played a lot of the classical repertoire. So the data captures kind of their phrasing and the way they're expressing the music. So the model is learning both kind of to compose and to perform at the same time. And as you can imagine in classical music, there's a lot of kind of structure where the theme comes back multiple times, and you see the model being able to capture some of this. For example, this here is the broken lines are the theme, and it comes back quite a few times in the piece. So this is a sample that the model generated, and so we were curious why is it able to do this? So we kind of looked into the box, and this is a self-attention kind of model. So we did this visualization. So you see it's actually able to kind of jump through the different parts of the piece and be able to catch the ones, like look at the ones that are relevant as it's kind of adding repetition and variation as it's moving forward. So I'll show you a quick animation of how this happens. So that's Music Transformer. And in this song, the version that Bob used is a melody conditioned model. So the model is able to listen to the melody and generate the accompaniment to what it hears. So this is the lament for Bob's puppy.
Vi vände hemåt, gick allting så fort. Där vid vägens kant var den sista gången vi sågs.
I forgot to mention this is a Swedish song, and Bob is also plays the accordion as his instrument, so he's playing it along to join the other parts. And so being able to use this piano model, Bob kind of mentioned this allowed him to not be limited by his own piano playing abilities, because he's mainly an accordion, and it kind of short-circuited the trial and error, the time to kind of build up all like different kinds of accompaniment and material, and it was able to give him some accompaniment that he hadn't thought of before. And he's actually presenting a paper at Kai workshop, and he's talking about how models kind of working with these tools allows him to express kind of the feelings and things that he haven't thought of expressing before yet. And so in terms of the workflow, it allows him to really get to the composing or the arranging part faster, and he feels like he's more in the flow and actually more able to express his vision, because he has a lot of material to work with and not limited by what he could play. So that was a kind of a showing some examples of how people are kind of making music with AI. So in the second part of my talk, I'm going to go into kind of more models and tools. And one theme is tool, collaborator, or competitor. This might depend on how we design the model, kind of sometimes from bottom up, or how we add on top kind of steering interfaces to make it more kind of to allow there for more entries, entry points for the user, and more fitting to the user's own process. So there's a lot of ways to design generative models, and traditionally we usually think of it as a little bit more bottom up. So there's data, there's sequences, and we kind of have a language model to generate, to kind of model like, okay, what given this, what can come next? So the interface for the model is this kind of left to right autoregressive interface. But what if we kind of took more of a top-down approach and thought of, okay, what does the user actually need? Like, how do they want to use this tool? And take more of an interaction-driven approach to designing these models. So I'll give you two examples of this. One is with the Bach-Doodle model that we created, and the next one would be for Music Transformer. So first, for the Bach-Doodle model. So this is a model that from the very beginning, we wanted it to be really flexible for people to use. So instead of like this left to right, we wanted to create an infilling model where it can, regardless of how bits and pieces of things you have in the score, it can fill it in. And also the generation process of this model also kind of tries to imitate how as we work as composers, we also do a lot of rewriting, kind of trying to putting down something and then improving it as we go. So just to show you kind of a little bit of the internal of how this model works. So if you've played with the Doodle before, when you're asking for a harmonization, this is what it's doing under the hood. So you see initially it's very uncertain about what's happening. It's really colorful, and then it gradually kind of fine tunes, tweaks the notes to make it nice. So if you haven't played with the Doodle before, this is the interaction.
Right, let's start with an E. E to G, back to E, to D, C, and B.
So here the user is putting in a song that he already knew.
This sounds great. Now let's click the harmonize button. It doesn't sound too bad, right? It sounds pretty awesome.
So a lot of people had a lot of fun with kind of playing with this Doodle, me myself included, just kind of tweaking things and seeing what comes out. But also at the same time, later on we did a study. So this work is actually by Ryan Louie, who is at Northwestern in this HCI program. So hopefully maybe he's in the crowd and can pop up and say hi. So so he realized when he kind of worked with users that because the user was only able to control the melody, a lot of them felt like the machine was like doing all the work, like the machine was composing and that the machine was the composer. And they were kind of left in a position where they just had to kind of take it or leave it, or just try again. And part of this challenge is because the output was not decomposable. It wasn't like the user can control a part at a time or a bar at a time to kind of really iterate on these smaller pieces. And at the same time, it's not steerable because it's a lot of this is kind of it feels like throwing a dice. But instead, the users had very specific intentions of, I want the music to build here, I want the ending to sound happier. So what Ryan did is he came up, he kind of identified these user needs and challenges and came up with a bunch of steering tools to kind of steer this model. So these include like new controls that you can control how similar, different, or how conventional, surprising, major, minor something is. And also be able to just control different parts of the music. This is something the model is already able to do, but depending on what the interface is exposing, then it might limit, the interface could limit or enable new possibilities. And we found that, yeah, with these steering tools, it helped improve the agency, how the users felt the model was controllable, and also how they felt it was more of a sense of collaboration, as opposed to the machine kind of being, I don't know, being the competitor and kind of doing the work. So that was an example how the steering interfaces and thinking about what kinds of user control is helpful, really allowed people to feel a different relationship with the model. And for this next project, we wanted to kind of get a step back even a little bit more and figure out, like, what do people want to do with these models? Are they trying to kind of find some, is this process kind of fun? They're trying to find something, or maybe there's a world where these models could be tools to help somebody kind of communicate through music, like really express something musically. And part of this, we wanted to build an interface that was a little bit closer to how people kind of in the creative process explore different things. So instead of kind of going left to right, thinking about more of a tree search approach where you can kind of steer at different parts of the piece. So this is a demo of how a tree-based steering interface could look like. And maybe I'll speed up a little bit. And here, so we're kind of exploring different parts of the forest. And so we decide this is the last kind of hiking trail that we want to look into. And we want to kind of sample through this to first like quickly realize what is the possibility in this. And now we want to create something that's a little bit more intentional. So through this steering process, I was happy at the end that I was able to find one that sounded like it would end. So we thought of this as kind of an Alice and Bob communication game where Alice, the composer, sees a card with a certain kind of emotion and story and wants to communicate it. And we would have two interfaces, one with the tree base, one is just kind of curating samples, and see which one kind of the composer Alice is able to use to produce something, the music that's able to evoke the imagery to a listener, Bob. And I think I'm kind of running out of time, so I'm gonna maybe jump through this part. And just say, like, we found the steering interfaces to be really helpful in kind of in helping the user make music that evokes the feeling a lot more. So since it's music, I thought kind of instead of tool and collaborator, we could think about instruments and improviser. And maybe a bit of a distinction is that makes it clear is instruments is something that somebody is playing. So in some ways it's a little bit more passive, but improviser is like a player that kind of comes and jams with you and has and kind of brings with it their own kind of agency and kind of the way they play and what they play and kind of to interact with you. And I'd love to, this is a work that I think really got me thinking in terms of George Lewis is asking, why do we want our computers to improvise, to be kind of more of create a system that does kind of assert a little bit more agency? Is that by kind of studying this process and building systems, interactive systems like that, it's this kind of jamming environment is actually a microcosm of kind of the social interactions that we have. And especially in jamming, there's a lot of encouragement to collaborate, to kind of listen to each other, to build on each other's ideas, kind of this kind of dialogue and conversation. So if we're building systems to kind of participate in this environment, it might allow us to actually learn a lot about kind of our social dynamics and what are the new ways to interact. And I'll end with another entry from the AI Song Contest to kind of to highlight how this process of they were asking they wanted to express this really kind of vague and abstract emotion that's very centered to kind of the Korean history and culture, this emotion called Han. So this process of figuring out can AI be used to express this became this whole discussion among the team members about what do you perceive as Han, as this emotion. So this encouraged the teams to share many references and also to think about what are the data sets that could that would allow this kind of emotion to be embodied. And I'll leave you with a short snippet of their entry. Thank you. I will end my talk here and looking forward to the discussion, and apologies for taking more time.
Thank you, Anna. It was very interesting. Yeah, we are running a little over at this point, so it may be that our discussion will have to go a little shorter because, of course, we also want to hear from fully from the practicing artist in. So up until now, what you've heard from are people who are working in the arts, but supporting themselves primarily as technologists in some sense. And now you're going to hear someone who is working in technology who supports himself primarily as an artist. And Moises, yeah, please, let's hear what you've got to say on this subject.
Oh. Thank you very much, Brian, and thank you to Northwestern University for the invitation and the other panelists. I think it was really interesting conversations that we had, touching upon Aaron's questions if the machine can actually make art by itself. And as we kind of came to his conclusion that the machine is always human driven, so it's part of a social relation. To the last slide, in Anna's slide that I also found quite interesting, can AI systems represent certain cultures? So more than the question of like machine agency and what AI kind of provides to the artistic context or to the artistic practice, I would like to talk about myself as an artist. So my name is Moises Horta. I'm an electronic musician and sound artist, and now technologist working primarily with electronic music and synthesis, sound synthesis, highly focused right now on self-directed research into what is called the neural audio synthesis, which is basically creating sound directly from data and from the waveform of the data. But aside from the technological side, I would like to focus on the cultural side. So my background is as a musician, as I mentioned. So I come from Tijuana, Mexico, which is a very interesting place because it's basically the border town between Mexico and the United States. These two very heavy ways of thinking of the world, very different cultures that exchange between them, but also have their idiosyncrasies, their uniqueness to both of them. So I was in a band for about 6 years called Los Macuanos, and we were basically the central idea of this band and the central concept that we wanted to explore through music is how do you engage with electronic music on a global scale, post-internet scale, and how do you provide a sound or a style of music that is reflecting of your social and cultural context, right? So in the case of Tijuana in Mexico, it's a very interesting place because you have a very big influence of folk culture and traditional Mexican and Latin American culture, but also from, let's say, quote unquote, more modern Western genres, such as noise music, traditionally noise music and sound art practices coming from what you would say the global north. So in this band, we wanted to create a sound that reflects this state of liminality that is Tijuana, this state of like between two cultures, and to create something new that reflects both our social context and our sonic environment. So I would like to play one track. In this band, we were 3 people, all of us electronic music producers working primarily with the laptop as an instrument, and also sampling sounds from different styles, so cumbia and salsa and various Latin American sounds, as well as engaging with sound synthesis and sound design and heavy sound processing. So with Los Macuanos, this was my first, let's say, endeavor into asking myself the questions of cultural identity in the context of, let's say, Western globalization, and how can one create art, and especially music, that contributes to an exchange, and it's not only about receiving a certain type of music that is mostly hegemonic around the world, but also engaging in the creation of new styles of music that are reflecting your own culture, your own social context. So this brought me into the world of electronic music and by extent, new media and computational media. And I would like to start my presentation with the issue of decoloniality and computing. So we've been hearing a lot about what a decolonial approach might be in the context of computing. And whenever I give these artist talks, I like to start out with this quote by the author Syed Mustafa Ali, where he states that for practitioners or artists or anybody engaging with computational phenomena to basically think about and reflect on your own geopolitical and body political orientation when designing, building, and researching, and as well as theorizing about computational phenomena. And secondly, to embrace this so-called decolonial option as an ethic and attempting to think beyond hegemonies, or let's say beyond the usual cultural centers where culture and by extent capital is being produced, and to kind of decenter them and challenge the Eurocentric and Western-centric ideas of universality. So when we're talking about universality, we're talking about presuppositions about art and about music that usually are regarded as universal, like around the world. But usually these ideas are coming from very specific contexts and very specific histories, usually imposed onto the global majority and taken as truths, right? So my work deals a lot about challenging these notions. One of my ongoing research questions is when we make art with AI and big data driven system, which cultures and human experiences are we representing, right? So as we saw in Aaron's and Anna's presentation, generative systems and deep learning systems are only reflecting the kind of data that we train it with, and also the rules that are designed and built into these systems. So for me, it's very interesting to think about why are these algorithms or these AI, so-called AI systems designed in a certain way, and to kind of challenge them and also see, and I'm very interested in the failures of these algorithms and the glitches of these algorithms towards their inability to represent beyond the training set or beyond the world view of the ground truths of different cultures that they were trained with. Another research question that I ask myself in my practice is what do AI arts making technologies potentiate in the creative process, and how can we engage with them in a critical way, in a non-hegemonic way, in a decolonial perspective? So with that in mind, I would like to talk about my first artwork. It's my most recent artwork called Nahualtia Tlatzontzonali, which it's titled in Nahuatl indigenous language, which is the most widely spoken indigenous language in the territory known as Mexico. And this is a visual music artwork originally commissioned by the Association for New Music in Berlin for part of a exhibition called Process and Protocol, where they commissioned different artists to engage with the medium of Web3 technologies and blockchain technologies and experimental music. So because a lot of my work deals with challenging the original purpose of how these algorithms are designed, I created a system where we can just bypass metaphors of tuning systems in the context of music, and we can just bypass different ways of thinking about music and sound creation, not by referencing sound with sound, but by creating a composition where the visual, basically a video synthesis algorithm, deep learning algorithm, is actually creating the composition through a transduction of the visual into sound. This sounds maybe a little bit complicated to somebody that's not so technically savvy, but I will show you what I mean. So the process consisted of creating an assemblage of two deep learning algorithms. One of them is StyleGAN2. And this StyleGAN2 was trained on a corpora of indigenous talismans, mainly from the region of Mexico and Mesoamerica, which is like currently Mexico City area, in order to create in a poetic way what these patterns, visual patterns, would create musically. So this piece was divided into 13 individual compositions released as NFTs. And each one of these is corresponding to a voice in the overall composition. So as you can see, each one of these columns is one of the pieces. So I'll just play one of them. And these are designed and crafted in a way that they are locked groups. So they're always, there's no beginning or end to each of them. So this is one of them. I'll play another one quickly. I know I don't have much time, but let's see. So when I work with deep learning technologies, I really like to explore their limits and also their creative possibilities for their sonic possibilities. So what kind of sounds beyond what they were trained originally when the algorithm was designed, what can they be capable for? So for my artworks, I try to engage directly. So I have to note that I'm a self-taught programmer and artist. So my experience is by engaging with the code and by engaging with the metaphors that came into designing this kind of code, I can better understand their possibilities. So with this piece, the process, as I mentioned before, is composed by two algorithms, StyleGAN2 and Rave, which is a neural audio synthesis model. And for this piece, I create an interface for composition in MaxMSP and in Python in order to kind of compose and find within the latent space of the generative audio model, the tonalities that can fit from this visual transduction into sound, right? So this representation, this interface is taking in a video, transforming that into the RGB data of the video into a very basic synthesis mapping, and then processed through a neural audio synthesizer, basically performing what is called as timbre transfer. So basically passing in a signal, an audio signal, and transforming it into whatever it was trained on. In this case, the data set for the audio was my own electronic music compositions from basically from the past 5 years, 6 years. I'll show you quickly here the interface, because I think it's also interesting to see what goes on behind the scenes. So as it was mentioned before, I see more the system or the arrangement of these deep learning models as the artwork itself, rather than the 13 compositions, right? So it's this idea of generative or system making as the artwork rather than the output. And the output is just a reflection of the system that I created, and also of the data and the representation that I would like to give this system. So another one of my projects, so I would like to talk about, is Semilla. And Semilla essentially is a neural audio synthesizer. Basically, it's model agnostic interface for directly engaging with this concept of the latent space in generative neural networks. Usually when we work with generative neural networks, such as GANs or variational autoencoders or any kind of model that has this latent space, we work with it in a very like black box kind of way. And this can be very frustrating as an artist, because one, as an artist, wants to be able to control or at least have a notion of what the system is doing for one to create an artwork, right? You just don't want to roll a dice and just see what happens, right? There's a greater need for controlling and understanding what these systems are capable of. So I built an interface to basically access directly the latent variable or the feature space of a variational autoencoder model. And when I say this is model agnostic, is that this interface can basically be applied to any kind of a generative neural network. So for a musician, this interface is mostly built as an impetus to artists that don't have the ability or actually are not interested in programming or actually understanding the code, but still be able to engage with generative models that it can be in a quick feedback kind of way. So I'll show a quick prototype of this piece. So this is the interface of Semilla, and basically this graph is one dimension. Each one of these points is one dimension into a 64-dimension, multi-dimensional space. So I guess this interface becomes a little bit as it doesn't quite fully open up the black box of the latent space, but at least as a human, it gives you some glimpses, like model-specific glimpses into how, like, what each of these dimensions is controlling. And by the engagement between the artist and this system and this essentially this interface, you get a better understanding about what region of these dimensions is what feature it's controlling the sound. So for example, maybe some of these points are controlling more the bass in the sound synthesis model, or the highs, or the melodies, etc. Right? So you have a little bit more of a playful and kind of a back and forth between the system, not fully understanding where it's taking you, but still having this element of surprise, but still having a little bit more control, rather than just like randomizing it and generating an output from it. The next piece I want to talk about very quickly is a piece called Oír, and this is my endeavor into asking myself, what is the role and what is the sound of human and AI co-creation in the context of global electronic music? So since moving to Berlin 5 years ago, I've been engaged in the electronic dance music scene, and especially the culture that's being created and being archived in a specific channel called Huang Berlin, which is basically a small cabin where many DJs from around the world come and play, usually techno music or electronic dance music. And they have this huge repository of DJ sets. So different styles of music, different ways of mixing and sampling different traditions of electronic music. So when I was working with the kind of big, deep learning models, I asked myself, okay, so what are the patterns emerging from such a big data set? And also, what is the role of the archive and culture once it is basically hosted in a platform such as YouTube? So I did a piece where I combined two generative models. One of them was a jukebox by OpenAI, trained from scratch on about 1,100 hours of DJ sets from this channel, and StyleGAN 2 to create a visual representation of all the patterns of all the people who have played in this channel, to create a semi-autonomous AI meta DJ. So it's kind of a system that DJs. So there's 3 full DJ sets, and I'll play the first excerpt from this one. So this is just an excerpt from the second episode of Oír. There's currently 3 full DJ sets, and all the waveform, or basically all the audio, is generative directly from the model, trained on all these DJ sets. And after, there was like semi-curation process on my part, but I tried to create a system that is semi-autonomous. I like to be surprised by the glitches, as I mentioned before, and by the errors of the system, rather than trying to find the perfect kind of beat that already presupposes my own biases and preferences. So I leave a lot of openness to the machine and the system to kind of surprise. And sometimes it just becomes really abstract and very noisy, but sometimes it kind of threads this fine line, which I guess as artists, we always want between something that is unexpected, but also kind of predictable, right? We always want to surprise, but maybe not completely alienate our public and the person receiving the artwork. So this is, I try to pose these questions on what does it mean that we can kind of automate these kinds of musics, and also what kind of new sounds when training generative audio, raw audio models. What are the glitches that that come back to the ecosystem of electronic music by learning from it? That brings me to my album Okachiwali. So Okachiwali in Nahuatl means future. And this was an exploration into trying to, again, represent my own culture or my own tradition as an electronic musician from Tijuana into the field of generative AI models. So I was part of a residency in 2021, invited by DataBots, CJ, where basically when you're an AI musician, a residency is basically they give you a lot of computational credits so you can train a model. And at that moment, Jukebox had just been released. And for those not familiar, Jukebox was quite a big thing in the neural audio synthesis field, because it was basically a transformer model that could generate quite convincing renditions on the audio domain, on the raw audio domain of different music, but not necessarily just reproduce the training set, but generate a system that is being able to be steered in different directions. So during this residency, I took it upon myself to train a jukebox model from scratch using a data set of tribal music. Tribal music is a electronic music genre originating from Mexico that mixes pre-Hispanic music, cumbia, Latin American rhythms with techno, and it has a very particular kind of swing and style. So my question was, is an algorithm like Jukebox, can it produce new versions of tribal, even though tribal was never part of the researchers and the engineers' ground truth per se? So I trained this jukebox model on about 40 gigabytes of music of this genre, with the permission of the archiving YouTube channel Word Tribal. So it's a YouTube channel that basically archives this sound, and this style of music is very internet based, because most of the music and the tracks get shared freely over the internet. It's kind of like a electronic music folk, electronic folk music. So this led me to release this album that is 60 tracks long and fully automized. So this output from this album that I released for free on my Bandcamp is fully automized. So I just decided to release all the outputs from the model, but also to release the weights and in a Google Colab notebook, so people can also generate even more variations. And I see this as a kind of poetic way to bring this style of music into the future, in this kind of like metaphorical way that AI has always been associated as a futurist, quote unquote, technology, or a technology of the future. What does it mean to bring this kind of folk and ancient sounds into this system and, you know, create with them? So I'll play one track. So I was quite surprised by the output of Jukebox, especially these parts where I think somebody here in the Q&A was saying about these errors. So that I guess is a big question, because for me, this is my artistic intent when generating with deep learning systems, that for me, these are the failings, to call them in a way, or the glitches of the system, which are actually not glitches. It's still designed to generate sound. But within this idea of generating a perfect kind of piece of music that totally emulates the training set is not very interesting to me, but rather these kind of abstract kind of deviations from the system. And so this album is about 5 hours long, and also signaling towards this bigger than human perception way of making art, that you can generate almost infinite variations of a style, and maybe within these you find something that your artistic vision can steer it. So, okay, I would like to just close with this and go back. I have some other pieces that I can talk about, but so I guess the conclusion to my talk is machines and their algorithms are culturally informed in their design. So if we are designing music making algorithms with AI, we have to think about for what kind of cultures are they optimized? Are they optimized for the whole human culture? In my opinion, this is not the case, but this is always a good way to kind of like signal towards a bigger conversation into who is designing these algorithms and where they're being designed, rather than if the computer has agency in itself and so on and so forth. Another conclusion is that deep learning systems are not universal. Going back to my last point, they are culturally informed. They usually reflect the human culture from when they're built, designed, and put together. So we need to think about who is designing these algorithms, for what is their purpose. And when we talk about data-driven algorithms, if we are just talking about like the future of art making, for who is this future? Because like whose data is being represented in these systems? So just as a way to kind of like an open question for everybody to consider, especially the engineers in the room and also other practitioners, to have more open conversations about these issues, because I think this can be, we can usually get caught up in the machine itself and the algorithm, but rather the culture, or whose culture are we perpetuating into the future is a more, in my opinion, a more pressing issue, rather than machine agency, or if the AI is a competitor, or like, as you can see, this is a tool for me. So my artistic intent is what you can make with this tool. And yeah, so thank you everybody for your patience, and I guess we're gonna continue to the panel.
Okay, thank you all. We got a little less time for the panel than I was hoping for, but some of what you all have been saying really maybe address some of the questions, like I think you, Moises, directly addressed Rachel Phillips' question there about mistakes in art. So I just wanted to, before getting to their questions, I want to hopefully get you to all put on your screens. And a couple of the things that Moises said sort of resonated with me around the following. So now we've got these deep models which are trained from some set of culture, and then they're being used by people. And often the size of the training data set for a deep model can exceed what you can expect a human, even an expert human artist, to be aware of in terms of the specifics of pieces of art. So, you know, train a deep model on 500,000 songs, and I haven't learned and memorized 500,000 songs. So when I'm using this, you know, there's not just the question of whose culture is being perpetuated, but there's a question of what happens when I am reusing, repurposing, and perhaps accidentally copying without even knowing other works by other people. What happens when my deep model outputs an entire passage with a a melody which I think is new, what's my guarantee that I'm not accidentally infringing on someone's copyright and essentially stealing someone else's intellectual contribution? How do you worry? Do you worry about that as an artist, Moises? And maybe Anna or Aaron, what could we do with our tools to avoid that kind of accidental appropriation?
I guess you can, I mean, I've been recently working with the large models, such as like the new like clip latent diffusion models and these really big language models. And what I like to do sometimes is to just, for example, do prompts in Spanish, because it's a system designed in English language, right? And maybe there is some other languages in the data set. So this is not necessarily responding your question, Brian, but at least it's kind of poking into this direction of like, you know, challenging the universality of the system itself. So far, I've gotten really interesting. So like by engaging in this like like designed view of like using these algorithms, I hope that I don't create something that's kind of like already existing, because it's not designed to work in specific languages because of the data set. The output could be something that's more unique because it's already kind of like looking at something that is not within the distribution of the data, or if that's my point, yeah.
I think these are hard questions for you know, society's been grappling with decades with this notion of like, to what extent is remixing previous ideas valid culture, and what is appropriation, what is copying. And so like a lot of it happens in our legal system with, you know, is it okay to sample James Brown grunting? Did Robin Thicke plagiarize Marvin Gaye, or Dua Lipa plagiarize the previous singers? And it was very difficult to define what exactly is using your culture versus, or using the culture around us versus stealing. With our technological tools, like you can certainly detect, did like the example you gave, can you detect that this passage came from some existing text if our tools allow that? Whether the tools will provide us that access is an open question. That's something that maybe should be determined by regulation. There are some interesting research techniques that attempt to identify to what extent did one training example inform an output. And I think that those will be really interesting to look at how they affect the future. But a lot of these questions end up being cultural and legal questions that they're very, very difficult to make good decisions about.
Well, I guess one question I would have about this, and I'm going to throw it to Anna, is that perhaps before, when I sampled someone, I had a much better chance of knowing that I was consciously sampling someone. You know, back in the, you know, it might be that, you know, I had a tape that was recorded off something and I don't know where it came from, but more often I had something whose provenance I knew, and therefore I could give credit, or at least know what my influences are, even if I were choosing not to give credit. Now with these, you know, AI tools that are informed by lots and lots of music, but we know from some other work like Daphne Ippolito's work that they can, when conditioned or triggered, whole passages which are straight up copies of existing works. Anna, you're deeply involved in making cool new interfaces for people to compose with. So what would be, how can you help us with this problem?
Yeah, I don't have answers for all of those parts, and I think we definitely need to think about all of them more. Maybe one bit is with a lot of these self-attention models, it kind of is a little bit more natural to kind of look into the box. For example, like we've done some visualization kind of showing as it's generating, how is it looking back into history. So I think there's been maybe Catherine Lee and others have worked on some paper and also pair people AI research. Really looking at how the attention structure is different when a model is copying, like kind of like just repeating what is memorized versus when it is relying on a lot of structure to generate new things.
Interesting.
So I think kind of like looking into the box and see how the model's thinking could kind of help inform how its thinking is happening.
I see. So maybe we could actually tell when a model is reciting as opposed to, we'll say, creating. Dury Long had a question. Let me just read it out loud. All three speakers talked about the importance of social processes in defining art and shaping the final artwork. In what ways do you envision people and AI interacting in the future to create art together? Are there new models of human AI interaction that you see emerging in this context? And this is for anyone in the panel.
I'll just give one example. So there's a variety of works that involve different users giving feedback to a larger system. So in the 90s, there was Scott Drave's Electric Sheep and Carl Sims's work where different people would upvote or downvote different generations of a system, and then they would, the system would evolve. You get something that was beyond the any individual's creation. And more recently, there's a system called Botto, B-O-T-T-O, from Mario Klingemann that is similar, that's using humans in the process of curation as well as voting and selection. And so it's like creating this sort of globally, collectively created artwork, in this case using, I think, GANs or similar, in a way that couldn't have existed before. So I think that's one example.
I guess in this way, I would say that the future of like AI and human collaboration would be like at least more engagement. I mean, there's going to be like the DALL-E approach where everybody has access to these APIs and just like write something and then get an output. So this is like already a really big, easy interaction, but it's not in the cultural interaction, right? Because you don't have access to what the model was trained on. It's people, the researchers sometimes are not releasing this data, so it's very difficult to pick what's inside or what is the culture being represented. Having said that, currently I'm in the, I don't want to talk so much about this new process, but I'm in the process of building a new music album where I'm asking many musicians, many electronic musicians to curate a data set of their own style. So how do they embody themselves sonically? Because I'm building this interface, Semilla, after I train these models, I will give all the artist collaborators their own models, and all the people in this collective work, the models and the tools for they can engage directly with this. So I think this idea of like creating something with the AI, but also creating with the data that you know is there and kind of embodying the neural network in some poetic way to say it, and then giving it back and having access to the tool, I think that's kind of like an interesting way to have a more feedback and kind of like a bit more transparent way to engage with generative neural networks, right? Because then it becomes, hopefully, let's see how this pans out. Like I'm kind of like nervous about how this project is going to go. But hopefully it's going to create a very interesting kind of collective composition that we won't know where anybody's kind of authorship or unique sound begins and ends, because everybody's going to be using different data sets, different style transfer, like timbre transfer tools, or just generating from the model from all this collectivity of musicians. So I'm just very curious how this is going to pan out, and maybe we can talk in 6 months and see what was the update on that.
Yeah, maybe we have to rethink from the ground up this idea that we've had that there is the artist. And maybe this is going to force us to understand that all of us, whenever we are thinking we're creating original artwork, we are a blend and a synthesis and a remixing of 1,000 different influences that we are aware of and that we are unaware of. And that maybe some of these AI systems are exposing or causing at least me to think about, is it even possible to make art where you're not somehow culturally appropriating from all of the things that you've heard before and all of the things you've seen before? It all goes into you, it all goes into the system. But I do have some hope that with maybe some tools like Anna just mentioned, or maybe, even something related to audio fingerprinting or image search, we could start to make reflective tools that could influence us by saying, for example, hey, this piece that you and I created together is related to these pieces where you can see the influence from my training data or other such things. I wanted to follow up on the cultural appropriation thing a little bit from a question from Manaswi Mishra. And this is from Moises. Do you think that a cultural appropriation emerges from engaging in specific cultural data and models? And now I'm not sure what this means exactly, or is it liberated for the future global AI artist? And so maybe just talk to us a little bit about your thoughts on a little more on the colonialism and data sets and whatnot.
Of course. I think this is a very interesting question, because when working with data-driven systems, you kind of think about what kind of culture you're coming from, or what is your influence, what kind of data are you reappropriating. And I've tried, with the pieces that I've talked about, I've tried to at least give some gestures into kind of like working with data where I feel I am part of the community of this, where this data emerges. So I think this is kind of like this situated approach, right? So like from my condition of being like from Tijuana, Mexico, etc., it doesn't mean that you can't be influenced by the whole planetary different cultures. Like I'm not, this is one point that I really want to be clear about. This is not about nationalism or just like embodying your own culture, because this is not the case. We're kind of like thinking about towards a planetary culture that we need to kind of think about all togetherness. But I think as a first step is to think about your position is very important. And then you can start creating like alliances with other people and seeing other perspectives into how this data is being represented. Of course, there's a kind of like postmodern way that you can just take from anywhere and then just sort of reappropriate and nobody's going to say anything, or maybe you're going to be called out by certain groups. I think it all depends a lot on the power dynamics that are at play in that process. Are you profiting from this culture? Like, what is your intention to engage with this culture? Is it like you're just trying to bring back to the community or create a dialogue, or you're just kind of capitalizing on it? Or like, I think this has to do more with that. But I can definitely see systems like Clip or DALI or this kind of stuff as like new folk kind of tools, because everybody can have access to them and create very almost unique, but at the same very similar kind of art. Like one story, like I was here in Berlin in the Sunday flea market, and I already saw like text to image, somebody selling like text to image art on the stand. So that's already kind of like permeating a folk kind of approach. So it's not only being in galleries or on the internet only, it's already kind of like on the real world and it's existing, right? So it really depends. Like, I think it's going to go in different kinds of ways, and it just like, it depends on the human, how we use it.
Well, we're getting a little short on time. Here's a really crucial question for some of the people in the audience. This is from Claire Krupella. And Claire asks, if we're just getting started with generative audio, are there any good resources you would recommend that we look at? And I think all three of you probably have some really good resources that people can maybe explore. So anything you have to share there would be great. You're all being so polite. I'm going to pick one of you to go first. Anna, what's a good resource?
Yeah, I'm definitely biased. For generative audio, Brian's lab does a lot of interesting work. Sorry, Brian.
Oh no, yeah. Generative audio is what she mentions, but I think in general, generative artwork, any resources. So I'm sorry, please say your thing again.
Yeah, it's for example, Magenta has like a blog post, and for a lot of the work, there's always like a collab and also open source code that you can play with. So I think it's been around for some time, for about 5 years. So you can kind of get a little bit of history in terms of the evolution of these models. And definitely, I encourage you to check out the AI Song Contest to kind of see the wide range of different kind of co-creative work that people are exploring.
So if they Google Project Magenta, they should get links to that. And similarly with the AI Song Contest, is that right?
Yeah.
Moises, how did you get started?
I actually got started into this free Cadenza course by Rebecca Fiebrink, machine learning for artists and musicians, which is not necessarily, I mean, it's for musicians, but it's more about creating supervised machine learning interfaces with sensors to create new instruments. So this was kind of my first foray into machine learning. Later on, I got into exploring the generative models like sample RNN. I also give workshops to introductory workshops into this field. So I always like to start with like sample RNN and WaveNet, because these, at least for like raw audio synthesis, these were kind of like pretty breakthrough. And also talk about like the history of like TalkNet and from the 80s, you know, so like different ways of like thinking about sound and generative sound. But definitely take a look at sample RNN and WaveNet. I think this is like to read the paper and to kind of understand what was before in the raw audio synthesis domain with the generative networks, and what happened after that is very interesting to see, especially on the texture level, which I'm quite interested in. So, yeah.
Aaron, what about you? What if someone wants to get involved in more the visual end of things? What would you suggest? I think you're muted.
I don't have a great answer for that for getting started with programming, because I started such a long time ago. But I will point to one tool that I found really useful for thinking about this, which is Artbreeder. I think it's artbreeder.com by Joel Simon. And it's a visual interface that lets you explore creation within a few different GAN models. So already GANs are no longer state of the art, but they're still really cool. And there's one model in there in particular called the general model, which is based on Big GAN, which just exploring with that, I just found really exciting and helpful as a way to think about like what exactly is the GAN doing. But you know, you really can't get into it without reading the papers and writing code, unfortunately.
Yeah, I guess I'll just mention one too. A friend of mine recently was talking to me about, like, if you look up DALL-E 2, how do you spell it? I think it's like
DALL-E2.
Yeah, and there should be a Colab notebook for that if you're already someone who knows Python programming, you can start playing with that pretty quickly. You mentioned that these are not state of the art anymore. Oh, we're already at 5:57. I think I better start to wrap this up. And the first thing I'd like to do is, just in case any of you have upcoming events, things that we should check out, I maybe just want to go through you and maybe in the order that you spoke to, so that you can tell us about those. Aaron, is there any work or events or things, if they wanted to follow up with you and the stuff you do, that they can follow up with?
I don't have anything to advertise right now.
Okay. Let's move on to Anna. Anything coming up that's cool?
Yeah, so for the AI Song Contest in mid-June, we'll be posting a short list of the top 10 entries, and then we're open to public voting that will kind of add up to like half of the team's points. So definitely check it out and kind of cast your vote and help us in this competition.
Nice. So they can actually influence who wins. And Moises, what about you?
So far, I guess I always post advances of my work on either social media, on Twitter or Instagram, so you can follow me on there. I just got a grant from the music funds here in Berlin. So I talked a little bit about this album, Collaborative, a Human AI album. So I guess stay tuned for that. It's in the coming months.
Okay. And maybe I'll I'll end with a little ad for what's going on with us coming up soon. Just as a reminder, if you want to know what's going on at the Center for HCI and Design, you can follow us on Twitter at @NU_HCI. On our website, hci.northwestern.edu, you can find links to the upcoming events you see here, the Tech, Media, and Democracy panel on Thursday, and Dean Kamen's talk on Friday. And we still have posted the description of this panel, so that if you wanted to follow up and see more about any of the works of Aaron, Moises, or Anna, you can click through there, and we've got links to their website, so you can begin following their papers, their artworks, their projects. I want to thank all three of you for really sharing a lot of interesting ideas, projects, and sort of visions for what AI and art making can be. I think you've definitively answered the question that it is more tool. If we work hard, we might make it a collaborator. And in one day, if we're very lucky in our AI building, it may become a competitor. But I think Aaron convinced me that not until it becomes a social agent, a truly socially aware social agent, will it be a competitor artist. So thank you all so much for your time. And I know you can't, we can't hear the audience, but I'm sure they're giving you a big round of applause right now. So we look forward to seeing everyone at one of our upcoming events, and I look forward to following your works as you all three move forward. Thank you, everyone.